Hello class, this is a video tutorial on triangle similarity. So I've drawn here just a good illustration as to get our idea as to what similar triangles are. So the best way you can think of it is if you notice how these two triangles have the exact same shape but they are not identical, meaning that the proportions of all these are similar to this one. So the shape is all the same, but they are not congruent. The formal definition is, if two triangles are similar, they will have three pairs of equal angles, as I've shown here in the illustration. This angle is equal to that angle. That's one pair. This angle here is equal to that angle. That's second pair. And this angle is equal to that angle, the third pair. So there are three pairs of equal angles, as well as three pairs of sides that are in proportion. I'd like to underline this because we are going to go more in depth as to what this means in similar triangles. Now, there are four tests, much like in congruency, for triangle similarity. They are, the first one is, if we can find that two pairs of angles in each triangle are the same, then the two triangles will be similar. The reason for that, by the way, you're wondering, in here there are three equal angles, but this one only needs two. Well, the reason for that is, since we know that these two angles are equal, it's easy to calculate that the third angle must also be equal, because the angle sum of this triangle will be 180, as will this one. So, first test, two pairs of equal angles. The second tests are, all three sides are in proportion. Okay, now I'm going to do a quick overview as to what it means about being in proportion. Now, if we take the longest side of this triangle, take 4, and we divide it by the shortest side in the triangle, so 4 over 3, and we do the exact same, sorry, not the longest, the middle side, and we do the exact same to that in the larger triangle. So the corresponding side to the 4 is 16, which it so happens also that 16 is the middle length side. So if we take 16 over, and if we take it and we take the shortest side in the larger triangle, which is 12, will these two fractions be the same? Well, if we simplify this fraction, it will actually become 4 over 3, dividing both top and bottom by 4. So 16 divided by 4 is 4, 12 divided by 4 is 3. As you can see, they are actually the same fraction, meaning this side is in proportion to this one, and this side is in proportion to this one. And this idea of proportionality, we can actually do it with any pair of any pairs of sides, meaning I could take 6 over 4, so the longest over the middle, and if I do the same on this triangle, the longest side over the middle side, and if we simplify these fractions, what do we get? Well, we can divide this by 2, so we'll get 3 over 2 equals, we're dividing this side by 4. a larger value. So we will actually, we can get a larger number, can't we? We can divide it by 8. Dividing it by 8, we will get 3 over 2 as well. As you can see that if you try it out yourself with any pairs of corresponding sides, so if we do 6 over 3 is equal to 24 over 12, you should get the same proportion. Moving right along. The other two tests we have are two sides are in proportion and an equal included angle. Included angle meaning the angle between the two sides are in proportion. So if you were to do 5 over 4 and test it with 10 over 8, it'll actually be the same. We can prove it here. 5 over 4, 10 over 8. We can simplify 10 over 8. It'll become, dividing both by 2, they are in proportion. So if we have two sides that are in proportion and the middle angle, the included angle, is equal. And lastly, what we have is we have one side is in proportion as well as the hypotenuse is in proportion. By that we mean, we'll test it here. Let's do 6 over 3. And so that's the longest side, the longer side divided by the shorter side. Let's do it with this one as well. We'll get 8 over 4. Simplifying these fractions, 6 divided by 3 is 2. 8 divided by 4 is also 2. So these two sides are in proportion and it is a right angle. So this is just a brief overview for triangle similarity. In the next video, we'll be looking at a few exercises and a few examples for these questions. Best of luck!